Hi guys, this is your lesson on writing and solving systems of equations from word problems. So what we'll be doing is kind of problem solving and writing a system of equations and then using the methods that we've learned over the past few classes to solve the systems, and those methods will be substitution and elimination. We do not solve word problems with graphing unless we are asked specifically to use graphing. I am on page 19 in your packet, so you can go ahead and open up to that. But I want to bring your attention to an old flashcard that we did back in Unit 4. So I'm going to put that up on the screen. And this was the flashcard we talked about problem solving. And so if you can remember back to, this is probably October or November, we used the STAR process for problem solving. S is to search, so we just read the problem and look for important information. T is to translate. That's going to involve a let statement or a chart. In the case of the systems of equations, you're only going to be doing let statements. And with a system of equations, you will be defining two variables. And then we would write an equation, and in this case, we'll be writing two equations. A is to answer, so we'll solve the system and answer the question, and of course write a sentence for word problems. And then we want to make sure that our answer makes sense, and in the case of systems of equations, I highly suggest you use your calculator to also check your answer because that's pretty easy to do. So the types of problems we did in Unit 4 listed over here on the right-hand side, we might be looking at very similar questions to what we did, except all of these were set up using a chart. And we're going to go ahead in this case and stick with the let statement because we're going to have two variables, okay? Even if you have a problem that can be solved using a chart, I want you to do this with a system of equations for now. And then in the future, you can decide which situation works best depending on what you like better and what the problem calls for, okay? So we're going to go through this four-step process. And on page 19 in your packet, there's a very similar process outlined for you on the left-hand side. Take a look at the top. The example that we have here, this is your word problem. Liverpool High School is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. We need to find the price of a senior citizen ticket and the price of a child ticket. So those are the two things we're looking for. So we are going to have two different equations. In this case, we're going to have one equation for each day of sales. There are other situations where it's not going to be day 1, day 2. It might be a different situation. So you really have to take each problem for what it's asking you to do. And then we're going to use those two equations and solve them as a system, okay? So we read the problem. We're going to reread and highlight some important things, okay? So as we reread here, I'm going to grab 2 different colors of highlighter. I suggest you have 2 different colors because you're going to write 2 different equations, so you can have a color for each equation, okay? So Liverpool High School is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. That sentence right there is going to give us the first equation for our system. Then it says the school took in $52 on the second day, so $52, okay, by selling 3 senior citizen tickets and 2 child tickets. Okay, notice I didn't highlight the unimportant words. I really only highlighted the important parts. So since we're looking for the price of a senior citizen ticket and the price of a child ticket, that's going to help us write our let statement. That's what we're looking for, okay? So we're going to I'm going to use X and Y, but you're certainly welcome to use other variables, maybe S for senior citizen and C for child. You just really have to watch out with certain letters looking like numbers, like S's can look like 5s and things like that. I'm going to let X equal, senior citizen ticket, and Y equal a child ticket. Now that's not quite enough information yet. What am I looking for about these things? Well, I'm looking for their prices, okay? So I'm going to indicate in my let statement that that's what I'm looking for. So I'm just going to put a $sign in here. So I'm saying I'm looking for the price of a senior citizen ticket and the price of a child ticket. That will remind me that at the end my answer is in dollars. Okay, let's write out the equations based on the word problem. So go back up to the top and take a look at the orange highlights. That's going to help us write an equation. If it says 3 senior citizen tickets, and I called senior citizen tickets X, then I'm going to write 3X. and one child ticket, and I call child ticket Y. So for and, I'm going to put a plus. One child ticket would be 1Y or just Y for a total of $38. So that equals 38. Now I'm going to do the same thing with the pink highlighting, okay? Now the $52 is the cost, so that has to go at the end. So the equation is going to equal 52. And I have 3 senior citizen tickets, so that will be 3x. And 2 child tickets will be plus 2y. Okay? Now, once you get your system set up, if you're understanding how to solve these systems, the rest should be pretty easy. I'm going to solve this by elimination, and it doesn't matter which method you use. You certainly could use substitution because you could get the y alone on the top and substitute for the y on the bottom. But since these are both in standard form, I'm going to go ahead and use substitution. So I'm just going to copy these down here because I need to change one of the equations, and I don't want to do that. Where I need to see the equations. Okay, so there's my 2 equations. And what I noticed here is that 3x will cancel out with 3x, but only if I make it negative 3x. And remember what we're doing here. If we change that to a negative 3x, let's change signs the whole way through. So instead of plus 2y, we're going to make it minus 2y, and feel free to cross off that plus sign if you want to. And instead of a positive 52, I'm going to make it a negative 52. And now I'm going to go ahead and add these equations together. My x's are going to cancel out. Positive y and negative 2y add up to negative y, and 38 and negative 52 add up to, how about this, I didn't bring a calculator over here, so I'm going to go ahead and subtract them real quick, 14. So that's going to be a negative 14 because the bigger number is negative. You can, of course, use a calculator to do that part. To get y alone, we're going to divide by negative 1, and y is equal to 14. Okay? So now you know, hopefully, that having one variable is not good enough. They wanted us to find the price of both, so we're going to go ahead and plug that in to get x, okay? So I'm going to go with the top equation. 3x plus y equals 38. So 3 times 4, 3x plus 14 equals 38. So I'm plugging the 14 in for y. I almost started plugging it in for x. So now we have 3x equals, if we subtract 14, we get 24. Divide by 3, and x is equal to 8. Okay? So now we have discovered the cost of a senior citizen ticket and the cost of a child ticket. The last thing we need to do then is to write a sentence to answer the question. So down here at the bottom, I'm going to say the senior citizen tickets cost, and then tell me what they cost. Those were $8. And the child tickets cost, and that was Y, so the child tickets cost $14. Okay? And then don't forget that you can use your calculator to check that answer. Okay, let's flip to page 20. I'm going to set up 2 different systems for you because I don't want to take up too much time here, and the point here is to understand how to set up the equations, and then I'm going to ask you to solve them on your own, okay? So we're going to do number 1. We're going to find the value of 2 numbers if their sum is 12 and their difference is 4. Okay, so nice short word problem. Since we have 2 numbers, our let statement is going to be let x equal one number and y equal another number, or something like that. You don't have to word it exactly like that, but you're just looking for 2 numbers. We're going to call them x and y, okay? Now, which of these words or which of these phrases is going to help us with our equations? The first one is the sum is 12, and the second one is the difference is 4. So that's how we're going to set up our 2 equations, okay? So the first equation is that the sum of the numbers is 12. So the numbers are x and y, and sum means to add, so x plus y equals 12. The difference is 4. Difference means to subtract, so x minus y equals 4. Okay? Now you can either continue the video and do this later, or you can pause the video and solve this now, but I want you to go ahead and solve for both x and y. And you can use any method that you want. You can use substitution by getting any of these variables alone and substituting in, or you can use elimination, and the one thing I would notice right here is that the y's would cancel out right away if you wanted to use elimination. Okay, so again, if you want to finish this now, pause the video. If you want to wait, then let's move down to number 4. Okay, so looking at number 4 at the bottom of page 20, the state fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 8 vans and 8 buses with 240 students. High School B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and each bus. Usually this last sentence is helping you write your let statement. We want to know how many students in each van and how many students in each bus. So I'll show you how to use different variables here. V equal number of students in van, and we're going to let B equal number of students in bus. Now, as I was reading, I was highlighting, so we're going to use the pink equation to write, or the pink highlighting to write our first equation. So 8 vans, we'll write 8V, and 8 buses plus 8B, with would be equals 240 students. Our second equation will come from the orange, 4 vans, so 4V, and 1 bus, so plus B, was filled with 54 students. And there's our system. So go ahead and solve that system, and I'll give you my personal opinion. I would probably use elimination. I would have to multiply first though, so you can either do the flip-flop method or you can just figure out what you could multiply one equation by in order to cancel out the variables. But you could also, if you prefer substitution, get the B alone on the bottom and then substitute that into the B on the top. So choose what you would like and go ahead and finish solving that. Okay, so when I check your homework next class, I will be looking for solutions to questions 1 and 4 on page 20. I will see you then.